In this lecture, I'll give the multiplication rule for the case of A and B. The general multiplication rule for events A and B happening either simultaneously or right in sequence with each other is the probability of A and B is the probability of B by itself times, multiplied, not added, times the probability of A given that B has already occurred. Or you could do it in the other order. It's the probability of A times the probability of B given A. So in a sense, you sort of act out the experiment. Okay, for example, let's say A and B are, we're looking at the events of A is drawing an ace and B is drawing a king. Okay, so to compute the probability of drawing an ace and a king, I compute the probability of drawing the king, which I know there's 4 kings in a deck of 52 cards. Then I multiply that by the probability of A occurring, drawing the ace, given that the king was drawn. Okay, there are still 4 aces, but now there are only 51 cards. Right. In this case, these are going to be the same, but it's not necessarily true in general. The result will be the same. Okay, there is a special case, and the special case is that if A and B are independent of each other, well, I drew a line through them, in that case, then the probability of B given A is the probability of B, or the probability of A given B is the probability of A. So this reduces to this formula. So let me write those right after the other so you can see them better. The probability of A and B is the probability of, I'll put the A first, times the probability of B given that A has already occurred. Now if they are independent of each other, then this reduces to the probability of A times the probability of B. This is the special case, and this is the general case. So here's an example for the multiplication rule. Let's say you have these boxes of five resistors, and you have the case of 2 bad resistors in the box of 5. A is going to be the event that the first resistor in the box is bad, and B is going to be the event that the second resistor is good. Alright, so there's 2 ways to do this actually. We'll do it first using the addition rule, or the multiplication rule. Okay, what is the probability? So let's write that rule. Here's a rule right here. Probability of A and B occurring is the probability of A times the probability of B given that A has occurred. So let's start with the probability of A. What is the probability that the first resistor is bad? Okay, well, I've got my sample space worked up here, and in the sample space I've got 10 possibilities, considering there's 2 bad resistors in a box of 5, so the 10 goes down here. And now, what are the number of times that the first resistor is bad? Okay, there's 4 of them. Alright, 1, 2, 3, 4. So there's 4 combinations with the bad resistor first over 10 possible combinations of a box with 2 bad resistors. So that's, okay, that's a probability of A. Now, once the first bad resistor has been selected, now what's the probability the next one is good? Okay, so if I now found the bad resistor to be first, I'm only dealing with this group right here. There's only 4 in that sample space, so the sample space is now contracted. Okay, so that's why there's a 4 down here. And how many of these events have a good resistor second? Well, there's 3 of those, so it's 3/4. Alright, so the probability of A and B is the probability of A by itself, which is right here, times the probability of B given that A has already occurred. Now in this case, because the sample space was so small and we could write out all the possibilities, we can just go back over and count the number of outcomes, the number of events associated with a bad resistor first and a good one second. There's 3 of them, and there were total 10 in the first case, so the probability of A and B just from counting was 3 out of 10, which is exactly what we got by the longer formula. Here's a longer example for the multiplication rule. In this case, we want to draw a royal flush. This is not the same as being dealt a royal flush, because in being dealt a deck of cards, a hand of cards, the dealer goes around the table giving everyone their first card, everyone the second card, everyone the third card. So you see, that's a little different from just pulling out a royal flush, just drawing a royal flush. But this is only for demonstration purposes, so we'll just go through this anyway. Okay, right now I've got 52 cards in the deck, and I wanted the probability of drawing a royal flush. So that's going to be ace, king, queen, jack, and 10 of the same suit. Okay, there's a first card. How many possibilities are there for the first card? Well, the first card is going to specify the suit. All right, so you could draw the ace, the king, queen, jack, or 10, and they're all in 4 suits. So that gives you 20 possible choices out of 52 cards, because at this point the suit hasn't been specified. Once you draw that first card, you've now specified the suit. Okay, which is what it says down here. Okay, there are now only 4 cards left that will work with the royal flush. Say I drew a 10 of diamonds. Now the only cards I can draw next are an ace of diamonds, 10, king, queen, and jack of diamonds. There's only 4 left. So that's why this reduces to 4. Also, there's only 51 cards left because we're holding on to that 10 of diamonds that we drew. Okay, now we've drawn the third. Now we're looking at the third card. There are really only 3 possibilities left. 3, and there's now 50 cards in the deck. And now when we get down to that last card, there's 2 possibilities. Okay, and now only 49, and we have 1 more to go. Okay, so for the 5th card, there's only 1 more card in that whole deck that I can draw to complete the royal flush. So there's 1, and there were only 48 cards I was drawing from. So to compute the probability of the royal flush, we multiply all those numbers together, all those probabilities together, and that's the answer. Okay, remember, and is going to be multiplication.